Okay, today we're gonna work on scientific notation. Alright, scientific notation is a way to write extremely large or extremely small numbers. Okay, so scientific notation, there's the standard form and then there's the scientific notation form. Alright, scientific notation form is the first one we have here. Alright, which includes multiplication. So it's going to be your base number multiplied by 10 to a power. The power can change or will change every time we have a different number. Okay, then we just have standard form, the way the number can be written out without the form here times 10 to power. So this is the standard form. So our first way, or the first way we're going to convert scientific notation, is from scientific notation to a standard number. So this is our first example. Alright, so now the first thing we're going to do is locate our base, and then we're going to check out to see what our power is. So we write that down, 5.12. Then we see that our power is positive. A positive exponent means we're going to move the decimal to the right. A negative exponent means we're going to move that to the left. So with a positive exponent, the number gets bigger. With a negative exponent, the number gets smaller. So this is to the 10th to the 5th power, which is a positive 5. So that tells us we're going to move the decimal 5 times to the right. 1, 2, 3, 4, 5. Alright, now we moved that decimal and we created hoops for each time we moved it. Now, those movements created holes in our number. So we have to fill those holes with 0. This is not the answer. You have to write the answer clean of any movement of the decimal. Okay, then once you write the bigger number, you have to go in and see where you need to drop your commas. And you know we drop commas after every third digit. So 1, 2, 3, comma. Alright, and we don't have to drop it again because we stop at the third number here. Okay, so that's how we look at scientific notation. It's like a direction on how to get to the number. Okay, you give us the base and then you tell us which way to go. If you follow the directions, you'll get to the standard number. Alright, so let's do another one. Alright, now we have 4.5 times 10 to the negative 6 power. Well, I write my base with the decimal where it's at, and then I go ahead and I see that this is a 6, but it's a negative 6. So the negative number tells us we have to go to the left. So 1, 2, 3, 4, 5, 6. And we drop in our zeros and we rewrite it. I see that there's 5 zeros. 1, 2, 3, 4, 5. 4, 5, and this would be our answer. So there you go. Alright, scientific notation is very easy. You find the base number and then the exponent tells you exactly where and how many times to move the decimal. So negative to the left, positive to the right. Alright, now let's convert a base number to scientific notation, or a standard number to scientific notation. So one thing about scientific notation is you see it has this, which is the base. Some people call it the factor. Okay, but it's the number that's going to be placed here will only be 1 through 9. It's only going to be the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it's going to have a decimal after that. How do we find this number? Well, we look at the number, the standard form, and we find the first number that's not 0. So we look from left to right. Oh, 5 is the first number that's not 0, and then we put a decimal after that. Okay, and now that means our base number is going to be 5.89. We have to write every number that's not a 0 into our base or our factor. How do we find the exponent? Well, the exponent can be found by simply moving the decimal to the end of the number, or where the decimal is located. So the decimal is located in this number here. I put the decimal there and then I simply move it. 1, 2, 3, 4, 5, 6. I move that decimal 6 times, So it's going to be a positive 6. So my scientific notation form of this number is 5.89 times 10 to the 6th power. Again, this base or this factor here will never be greater than 9. This number right here will never be greater than 9, meaning it can be 9.9, but it won't be 10, right? So it will always be a single digit here. It can be 1, 2, 3, 4, 5, 6, 7, 8, or 9. Let's have another one. Alright, so now we have a number 0.004509. We want to make this in the scientific notation. Same rules apply. You find the first number that's not 0. So that's a 0, so we're not going to put the decimal there. That's a 0, so we're not going to put the decimal there. Oh, we have a number that's not 0, 4. So that's going to be 4.509. Well, I just said a minute ago that we're not going to write down any number that's not 0, or we're not going to write down any zeros, right? Well, you do have to write down 0 when it's a part of the number. What do I mean by that? When it's surrounded by numbers that are not 0. So because this 0 is surrounded by the 5 and the 9, we have to write that in our base. So now I put the decimal here and I move it to where it is in the number. Okay, so I start here and I moved it once, twice, 3 times. I moved it 3 times, but I moved it to the left. When you go to the left, that's a negative number. Okay, there you have it. Alright, so let's go over some of our examples in our book. .9 times 5, and let's see if we can get a little bit tighter here so we can see. No, we can't. Let's see if I can make this a little bit closer. There you guys go. A little bit better. It's a little bit better, right? Alright, so now we have 3.9 times 10 to the 5th power. What I'm going to tell or ask you guys to do is to write it again. And then go ahead and do what it asks you to do. So that's 3.92, and it says to the 5th power, so we're going to move to the right 5 times. 1, 2, 3, 4, 5. Drop that in there. Rewrite the number. Okay, well, let's look at this one. 1.34. Now it says -2, so we're going to move which way? To the left or to the right? Yes, to the left. How many times? Twice. Once, twice. Remember, always rewrite this number, right, without any of these drawings on it. Alright, we'll do one more. 7.1. That's going to go 4 times to the right. 1, 2, 3, 4. 71. Alright, now we're down here. Okay, and we have to find our base number. Oh, okay, so it's going to be base times 10 to a power. Now it's the first number that's not 0, correct? So 0009, so it's going to be 9.8. Well, I put my decimal in and I see how many times I move it. 1, 2, 3, 4. Because I was going to the left, that's going to be a, you guessed it, negative number. Alright, let's find our base number. So we're looking for the first number that's not 0, and 3 is the first number, so it's going to be 3.47 times 10. See how many times we move that. Put the decimal right here and move it physically. 1, 2, 3, 4, 5 to the 5th power. Alright, let's do one more. Now this one gives some kids some trouble sometimes. Alright, this 5, okay, is the first one. You can definitely put that decimal there. Some kids are worried because there's nothing behind it. Should I put it in front? Keep the decimal in behind the 5. Okay, stay with the concept. So it's going to be 5. We don't have to write 5.0. We're okay with that. We understand that 5 is the same as 5.0. Okay, and then we're going to move it. 1, 2, 3, 4, 5, 6. Now I moved it 6, but I moved it to the left, so that's going to be negative. Alright, so that is scientific notation. Okay, again, we'll go through it very quickly. You find the base, okay, by finding the first number that is not a 0, and you put it after that. Alright, then you simply move that decimal over. 1, 2, 3, 4, 5, 6, 10 to the 6th power. Okay, you come back here, and how do we change it? You figure out, you write the number down, and you figure out that that's your base and that that's your power. Your power tells you how many times to move and what direction. The 6 is positive, so we're going to the right, and it's 6, so we're going to move it 6 times. 1, 2, 3, 4, 5, 6. Drop the zeros in. There you go. Alright, have a good one. Bye.